Thank you so much, Rico, for this wonderful introduction. Thank you all for being here, for surviving lunch. Oh, that's not easy. Last part of the session. But I'll at least try to be entertaining. As Rico mentioned, I'm coming to you from Boston, from the MIT Media Lab, City Science Group, where we work a lot on this topic of urban science, data-driven design. But again, since you just survived lunch, I want to start with a provocation. How many of you know who this person is? Who is it? Frank Gehry. Who is Frank Gehry? Or I couldn't put it better. That's Frank Gehry, who is well known for his pretty lavish and interesting work using a lot of computation, if you're interested. But do you know why he's flipping the finger as well? So yeah, not to put you on the spot. There you go. So you saw my presentation before. 2014, a press conference, Frank Gehry asked a question by a journalist, didn't really like the response and flipped the finger. This became a meme in the world of architecture and design. Many people remember that image, but not many of them remember what Gehry also said during that event. And I want to quote, "In the world in which we live today, 98% of everything that is being built, designed, and developed is pure blank." I'm not going to repeat the very Brooklynite term that Gehry used there. But Gehry, of course, reflected on the fact that his 2% actually enjoy unlimited regulations, almost no budget restrictions, or any technological constraint. These are very sophisticated buildings. But his words resonated with me concerning the rest of the 98%. How do we fill that blank? This is almost a cliche, but when we put things in perspective, when we realize that half of the world population, or more than that, is approaching cities, about 2.5 billion additional people are moving into cities by 2050. These are hundreds, if not thousands, of 1+ million resident cities in which we are mostly seeing the replication of unsuccessful urban models. I don't think we can define that as anything else than an urban tragedy. And the reason I'm saying it's a tragedy, it's because we are in the most prosperous, healthy, successful moment of human civilizations. Now, I know it's hard concerning today's news all over the world, but it's a reality. We live longer, we're healthier, we have more money, but then for some reason, we continuously decide to build our new cities like that. This is the 98%. And I think we need to ask ourselves why. Why do we commit to this type of models versus anything else? I'm not going to be able to answer all of these questions today, but I'm going to try and start. This is 3 moments in the zoning and regulation code of the city of Los Angeles. 1946, 16 pages. 2011, I cannot capture the 12 binders of rules. This is the 4,007 pages of New York City congestion pricing environmental regulation code. I encourage all of you to spend an afternoon and read through that. And this is San Francisco's $1.7 million and 2 years project for public toilets. This is where we are. This is how we build our cities today. The reality is that we have created traditional planning processes that are slow, bureaucratic, filled with complex legal terminology that occasionally favors top-down and highly centralized design processes in which participation, public engagement, and collaboration is deeply undesired. And I think the question we want to ask ourselves is whether we are entitled for a better process, something that comes out of the 21st century and not from the 19th century. And so these questions and others motivated myself and my team at MIT to think on an alternative process. We call this Cityscope, which stands for an urban modeling and simulation platform. But Cityscope, despite its physical incarnation, is not so much of a tool or a specific technology, but what we like to think of as a new urban process. This process is consisting of these 4 themes: insight, transformation, prediction, and consensus. Very hand-wavy terms for this hour of the afternoon, right after lunch. But for the time I have left, I'll try to take you through these 4 stages or 4 themes and explain how we augmented, excelled, and in some cases even replaced traditional planning processes. We begin with insights, which is where we understand the current state of the city. With that in mind, we build a series of urban observatories, basically physical, tangible platforms that allow us to understand and see different layers of the city, from land use, urban networks, energy, wind patterns. But then we struck a collaboration, a city science lab collaboration with the city-state of Andorra in between Spain and France, about 80,000 inhabitants, but 8 million tourists a year. In Andorra, we gathered several years of countrywide and anonymized location data, which allowed us to start and analyze the behavior of both tourists and locals, pinpoint hotspots, congestion, and other behavioral patterns during large public events like the Cirque du Soleil and Tour de France. Later, as we continued that collaboration, the data that we got was actually improved, high resolution location data, and with that we could start and analyze activity patterns that show which urban areas in the city create long-lasting, consistent, and diverse behavior. So to kind of explain these words, this is a sequence of clusters of events during the day. We basically try to find which clusters persist throughout the day in a long-lasting and persistent way to show to us, and this is what we did next, to show to us which urban features are actually associated best to that behavior, meaning whether it's a bar, a restaurant, or a church that pull people into it. Now, when we model that, we can start and see which areas of the city has the best potential to create these vibrant and active places, and then also create some kind of a predictive model on what are the amenities and functions that might need to happen in order to create those activity clusters. Now, what started as a tourist project flipped during COVID-19. Instead of looking at places we want people to go to, we actually started to find patterns in which behavior and activity might contribute more to the rise in cases in the city. Left side, pre-lockdown, right side, during the lockdown. But I think the really interesting part here is all the white around it. These are the touristic locations, which, as you can see, are not in a high potential to contribute to the rise in cases in Andorra, and that's because they were not really communicating with the general population, ergo an economic output that we can provide to decision makers. Now, we don't leave these insights on the screen. Instead, we build them into tangible, physical, three-dimensional platforms in the city itself. This is from our innovation center in Andorra, which then was extended by local researchers to do other types of research. Okay, so we looked into the current state of the city through insights. But then the second phase, transformation, is where we try to explore changes to the built environment. So not just the current state, but how do we adapt? Since the 1950s, we have used and harnessed the rigidness and accuracy of computational systems to excel different design tasks in the city. I'm not sure how many of you know, but the first computer graphics in history from 1961 was actually depicting driving through a planned highway in Sweden. 1962, Ivan Sutherland at MIT creates basically CAD, as we know it today, computer-aided design, as well as the first VR headset. All of that in his PhD dissertation. If somebody's looking for a competitive dissertation, this is a good one. A few years later, the Architectural Machine Group, 1970, created a tool called SICK. SICK was an AI, 1970, AI robotic interface that designed a micro-city made out of toy cubes. The city was sort of designed in a reaction to a chaos created by living gerbils. See them down here. And as for the success of this experiment, I'm just going to quote Nicolas Negroponte, who designed this tool. SICK actually tended to kill all the gerbils. 1980s, Berkeley Environmental Simulation Laboratory creates highly detailed urban models to render the experience of driving and moving through the city. This is not an image of a street, a real street. This is an image from the model that with climate and environmental simulations basically rendered how would be the experience of driving through that area. 1990s, Hiroshi Ishii creates Tangible Bits as a series of tactile, real-time, and iterative urban design tools. Here, real-time shadow analysis. And then together with Ran Ben Joseph, they're creating the Luminous Planning Table, which became sort of comprehensive, iterative city planning platform. That's 30 years ago. So as you can see, the seeds for an urban human-computer interaction platform were planted some decades ago. And when we continued that work, one of our first iterative and interactive cityscope examined a very abstract notion in the city, which we talked about before. This is the urban zoning envelopes. Those are the legal frameworks that determine everything about the building usage, bulk, shape, form, usability, etc. Now, I'm sure most of you know that zoning was created in New York in an effort to curb the mass urbanization of the early 20th century. And as you can beautifully see, this is the wonderful drawings by Hugh Ferris, 1929, and this is the result. So this is the three-dimensional representation of the zoning. This is how the zoning impacted New York. Great success in the early days, but then within a decade, zoning quickly sprawled all across the United States. And you've seen this slide before, turning into an endless paper trail and a complicated legal terminology. And so the purpose of this early cityscope was to codify the building code, or in other words, translate the abstract legal terminology into computational building blocks so that the evaluation of new urban developments and designs could be done in a logical way in respect to the current zoning law and the building code. Moving away from these complicated slides, we packed this idea into a zoning simulator, which then allowed designers and users to evaluate each one of their designs against the current zoning law and regulation. So you can see one of our students here playing with Legos, but as they do so, the system highlights challenges, issues with the current zoning, and there is kind of a constant conversation with the regulation. Now, I have to emphasize at this point, today when I present this project, that this is a pre-LLM work. So we actually had to read through those thousands of pages, codify them, and then run this simulation. But we then did also an HCI study in which we compared traditional planning processes, pen and paper, to the new design process. And I really like how The Guardian, who picked up on this project, asked, Lego, can the most analogous of toys really be a modern urban planning tool? But that was kind of a motivation boost for us. And beyond zoning, we extended this platform to allow different stakeholders and communities to explore different design scenarios. Again, not just about zoning, but also land use, public and private spaces, different energy models and mobility modes, all of them packed into this iterative and interactive Cityscope platform that does real-time metric and KPI analysis. You can see my colleagues here playing with the Lego, and as they do so, the metrics updates. One of my colleagues is actually here in the crowd and going to talk to you in a second. But all of that happened inside our lab. But in 2017, we actually got an opportunity to test this in the wild. This is the first time I present this project where I can just point out and say it's over there. So if you leave the room, you can see this is the Grasburg area here in Hamburg, which the city dedicated as Hamburg's future innovation and entrepreneurship neighborhood with many working places, many offices and industries. And as you can see in this older map, very, very close to the city center, so a great potential. But from us, the quest was not to build yet another solution for Grasburg or design it so much, but instead to evaluate the different designs that were proposed by a series of world-class architects or planners through the same set of metrics and KPIs. So these are their designs, and this is the simplified computerized version of each one of these designs. And specifically, we tested each one of their designs through a set of 4 major metrics: noise, access, stormwater runoff, and GFA. And I'll just say that the team, including the team that worked here, did a great job because the tool was both dynamic and real-time and allowed the design teams as well as the evaluation team to test these algorithms in real time versus what traditionally can take weeks, if not months. But this effort also motivated us to extend the Cityscope architecture so that it could become an online, open-ended, and open-source platform, allowing different researchers and communities around the world to build their own tool. So now you don't have to necessarily build a physical, tangible platform, but instead you can run it directly from your phone when you don't have the same resources. Okay, so We gained insights, and then we tested different scenarios through transformations. But now what we aim to do is to evaluate their impact on behavior and experience while we move through the city. In most cases, when you talk about predicting behavior or predicting movement, we think about the relationships between how the physical form of the city impact the way we move and vice versa. And so in that in mind, in this project, we used mode choice model, which is a very common, typical mobility modeling technique with the Cityscope interface so that we can predict the mobility habit changes giving small-scale intervention to the built environment. So you can see my colleagues here playing with the design of a small neighborhood and then impacting the entire metropolitan area of Boston. Another way to predict that work, and you're going to hear again from my colleague in a minute about that more, is an agent-based simulation. Here again in Hamburg, this is the Hauptbahnhof, the central train station, where we tested micro-interventions, really the change of a location of a bus station or turnstiles or some signage, and see how that might impact the movement of maritime tourists. And lastly, on ABMs, this is a project we did in the Champs-Élysées Boulevard in Paris with the city of Paris and PCA architects, where we wanted to see what would be the impacts of changes to the boulevard in terms of emissions, commerce, and tourism. But every once in a while, what we want to measure or to predict is not how people might move, but what might be their experience as they move through the city. What do they feel? And this question of planning from the user perspective and the experience intrigued urban thinkers for over half a century. This is, of course, Jane Jacobs. Kevin Lynch, again from MIT, also discussed this idea and coined the term imageability. Imageability for Kevin Lynch was the way to observe different urban elements and the way they are organized as an instrument for wayfinding, navigation, orientation, as well as safety. In 1960, 1964 actually, Kevin Lynch mounts a dash cam to his car and go on a road trip with students across 5 metropolitan areas in the US, basically filming the experience of moving through the city and actually expediting the video so you wouldn't care so much about the details of the buildings, but what do you feel? What is the sensation of moving through the built environment? And he writes, and I think that's a beautiful quote, to understand the role of images in our urban lives, we need the idea of imageability as a proxy for urban design. But here is the problem. Unless you are as wealthy as the design team of the Lincoln Center, in 1960s, you have no way of imagine how a place might look like if you don't build a men scale model in which you can stand, right? There is no way at the time, at least. So in this project, fast forward to 2019, we aim to simulate future cityscape experiences in real time. We used here what I think would be described today as an ancient technology. This is generative adversarial networks. In the world of AI, this is already passé. But specifically, this platform translated user interaction into generated streetscapes using the real-time GAN model. To put this in context of the previous work by Lynch, every time when the design teams are working on iterating the streetscape, an image of the city appears in real time on the right side there. Now, again, this is a prehistoric AI, so the quality is not great. Today, with the new diffusion models and other generative models, we can perform really unrestricted generation and prototyping and achieve almost real-time guided urban visualization that is really unrestricted by any of the previous restrictions, and we can change, with a change of word from one place to another, from day to night, etc. Now, we recently combined these ideas with a speech recognition model. So instead of having a tangible interface, we can interpret the user conversation and then visualize the streetscape on the go. So 2 of our students, Letty and Vinci, are mounting a microphone. They're having a community engagement, a simulated community engagement session. But as they do so, a new image of the city appears on the screens around them, allowing them to better visualize their ideas. Okay, so we talked about simulating how we move with ABMs and other mobility models. And we also talked about the way generative models can help us to visualize the experience. But how do we bring them together? And so in our current research, and this is just published a few weeks ago, we're trying to simulate how both human behavior and experience in the built environment might be analyzed through generative models. More specifically, we're developing an LLM agent. LLM stands for large language model. And an agent in this case is both the LLM agent as well as a physical agent that moves in a space that could move around an existing or a simulated environment and then reason, and that's really the key word here, reason about their experience as they move. As an example, this is a student that was tasked with meeting their professor somewhere in the lab, and this is the only restriction. We don't create a path, we don't give a shortest path or any of these traditional navigation algorithms. We basically let the agent move by itself and then reason, have a conversation about what they feel and how that impacted them. So that was interior. This is an exterior scene where an elderly person is looking for a shaded plaza to rest. And travel agent really can help assess the design of these spaces based on what the experience is. Now, on the bottom, you can see cross the street safely. And if you wait for a second, you can see it's actually crossing in diagonal. So it's really unsafe. However, it does something interesting. Just before they cross, they look left and right. Again, we never asked them to do so, but the agent has sort of its own emerging behavior, which was interesting. Now, when we simulate those agents using generative environments, with a change of a word or some minor changes to the profile of the agent, we can get a new simulation. So all of these simulations are running on the same three-dimensional environment, but with a change of a word from summer to winter, from day to night, from Boston to Tokyo, we're getting a new simulated environment that we can test and evaluate how it impacts the agent movement. This is some results from some of these simulations. So this is a spatial result, how the agents performed. You can see, for example, during the night, the agent's decisions are a bit more sparse, meaning they're lost a bit more. That it's harder for them to find where they are, which makes sense. During the night, we have less visual cues. But since we're using an LLM here, we can also ask what was the agent thinking about. So for example, in our experiments, you can see that the agents are really, really focusing more on physical spatial features, the urban form, the pathfinding and navigation, and less so on other elements down here. And I think more importantly, we can perform sentiment analysis, which is our way to understand what was the agent thinking and how they felt about the environment. So it's not just about the words or the terms they were using, but really what was the general sensation as they moved through the environment. On the top, successful experiments, meaning the agent reached their destination. On the bottom, failed ones. And I think very clearly, very easily, you can see how when the agent failed to perform their navigation task, that's because there were a lot of decision points where the agent was looking left, right, was showing confusion, and eventually lost their path versus places where the agent was successfully performing. Okay, so what is it good for? We imagine travel agent as part of the designer's toolbox, where we can use it for applications such as urban safety, accessibility, and spatial equity. So you can imagine testing it on 10,000 agents, each one with a different demographic background, age, accessibility challenges, and then seeing how they will perform in the same built environment. Again, think about that as a tool in your toolbox. But up until this moment, everything that I showed you could still take place behind the curtain. We can have these tools, these technologies, or processes used by decision makers in their own small rooms where they plot on how to design the city. But the last theme and the last two projects I want to share with you today deal with packaging all of these ideas into a public-facing, community-facing decision-making process. One of our first real-world out-of-the-lab experiments with using Cityscope for participation was in the Boston BRT project. BRT, to those of you who are less familiar, this is a bus rapid transit, basically an enhanced mass transit system that bring together dedicated lanes, prepayment, and improved bus stops. In the case of the city of Boston, 5 of these lanes were meant to meet here, a place called Dudley Square, which was for many years a vibrant, well-served and connected community. But in the 1980s, the MBTA, Metropolitan Transportation Authority of Boston, decided to ruin this station, run a highway here, which never got built, and basically contributed to the overall decline of the Roxbury area over the next few decades. Now, disclaimer, the next slide might be slightly triggering, but no worries, this lady is in a good shape. This is just part of a protest against any kind of new public transportation projects in the city of Boston. And that gives you, I think, a sense of the atmosphere to which we were brought into this project, where we were not asked again to be planners of a new BRT system, but instead to create a buy-in and an outreach process with the local community. The task was not to design it, to design the BRT, but instead to create this co-creation with local communities, stakeholders, and even students, so that we can involve them from the get-go. And I think that that's a key learning point for us from this project. You don't come with your community engagement process when it's ready. You want to design the community engagement with the local communities. So in this case, you can see the students who actually physically build those models with us, gave us a lot of insight about the neighborhood, and then ran the community engagement process by themselves instead of us. One of the main takeout from the conversations was that in order to understand what is a BRT system to begin with, we actually need a multiple set of tools or platforms. We had a regional scale where designers could offer a citywide understanding of the BRT system and its impact on each member of the community. Here, participants could design their own daily commute and then were given insights regarding waiting time, access to housings and jobs and amenities, as well as potential budgeting increase. So again, the idea here is not to become an urban planner or a transportation planner, but to become a well-educated citizen as part of the decision-making process. The neighborhood scale used one of our tangible platforms to define the most suited locations for the BRT station in the vicinity of the Roxbury area, while presenting, again, feedback on commuting time, pollution, and cost of each one of the scenarios. And finally, and I think that was one of the main takeouts from the conversations, what is the impact on the street itself? How does a BRT street looks like compared to a traditional street? So you can see that interactive platform that allow users to basically toggle between traditional street, new street, and see the impact on mobility performance of the area. Now, I'm not going to go deep into the results, but I think the key takeout was that about 25 to 35% increase in the knowledge and ability to make better decisions was prompted by the participants, which was really the goal here. The idea was not to convince anyone that BRT is good or bad. It was about how knowledgeable are you to be able to take part in a conversation moving forward. And I think from the standpoint of MIT and our team, this was also an amazing learning opportunity towards the last project I'll show you today. What does it mean to take these ideas into the wild, to leave the warm confines of the lab and test these notions as you move into the real world? And the last project I'll show you here today actually centered Cityscope in the heart of heated decision-making here in the city of Hamburg. So in 2015, we start this beautiful collaboration with the city of Hamburg and the HafenCity University. The first few months, we were asked to work on the upscale development of the Alba riverfront and HafenCity. And then we also looked into the design of the Olympic village as part of Hamburg's Olympic bid in 2016. But by the end of the year, all of these first world problems had to be put on hold as the city realized that the wave of refugees coming from Syria and Africa is projected to bring about 80,000 refugees by the end of the year. These are 500 people a day to which the city had no viable solutions. This is actually from Berlin, but no viable solutions and only had to use those ad hoc housing solutions. And so once again, this is the atmosphere to which we enter. As a result, the public sentiment in Hamburg changed and the mayor's own government became uncertain. That's what I hear. You can correct me later, but I usually tell that and nobody contradict. And in response, the mayor showed up one day, that's how Geza tells that, and demanded an out-of-the-box solutions for the refugee housing problem, demanding only 3 criteria. It has to be a bottom-up, a citywide, and a collaborative decision-making process. Now, I really like to show this slide because this was a city science lab at the time. No 2 stories, no fancy building. We literally hang the sign that day. But with that emergency, we forced ourselves to basically very quickly learn on the go and copy paste everything we knew from MIT here in terms of public engagement, participation, Cityscope platforms, so much so that exactly 3 months later, you can see here the mayor of Hamburg at the time inaugurating the Finding Places project by holding a Lego brick. I like how the Zeit newspaper put it, swarm intelligence, doing instead of complaining. You want to complain, stay at home. You want to participate and be an active member of your community, come to HafenCity University and take place in this project. And over the coming months, we hosted more than 30 community events with about 400 plus participants. Each of these sessions was started with an overview of the current refugee situation. This is insights, basically what is the current state. But then from there, the group would transfer to an interactive neighborhood scale cityscope on which Lego bricks would mark the addition of refugee housing to the site. From a technical standpoint, the user interface translated the interaction into GIS features, which and then created an analysis for each one of the scales, the city scale, the district, and the local neighborhood. By the end of each session, each of the teams would share their feedback and compare their results to the previous teams in play. And I think that's another key takeout. You have to gamify these processes. Even in a heated situation like refugee housing solution, which definitely a complicated question, by gamifying it, by comparing the teams, by showing them how other teams were performing, you create this tension between the players, if you will. And in that sense, some cases we even had groups going back to the tables and adapting their designs. Overall, Finding Places had engaged about 1.2 million residents in the city and identified over 160 sites. Some, as I hear, even began construction while we were still doing the community engagement process, given the fact that the major bottleneck of community outreach was resolved. And I like the quote here by Schultz at the time, the mayor, then chancellor, now I'm not sure, here is your chance to examine whether what makes sense in theory is also suitable in practice, which I think is a great representation of Finding Places, but also generally the notion of taking human-computer interaction platforms for the betterment of design processes in cities. Finding Places became a tool in the toolbox of these organizations in the coming years, and so much of the wonderful work that the lab here in HafenCity is doing today, I think to some degree could be connected or stemmed from Finding Places. Poorly, the table from Finding Places is still here. So if you look over there, you can see it now used as a regular table. But here's the thing, that's actually a great representation to the fact that the technology is in the background. It's really not the center of things. It's just a way for us to create a conversation, to have a common table for discussion. I've demonstrated some work from some of our city science labs. So in the past decade or so, we're creating this city science network of different labs. We have Hamburg is one of our earliest members, and the Negev lab, who are here as well as our newest one. I would say that in many of our labs, I would say today all of them actually use the ideas behind Cityscope as one of their main drivers for research, collaboration, and public participation. And again, especially here in Hamburg, where these tools matured and grew so beautifully. Okay, before I let you go, and I saw the sign, you invited me to a digital twin conference, but I did not mention the term even once up until now. So how do we potentially get there? How do we get to this real digital twin? And I have to say that I was thinking a lot about that with myself. What does it mean? What is a digital twin today? Until I came across this wonderful cartoon by Edward Steed, who is a New Yorker cartoonist and artist, titled "That's Where You Are, That's Where We Are Right Now." As you can clearly see, the cartoon shows a city model that is so pristine and accurate that it even resembles its own viewers. Right? The person looks through the window and see himself through that same window. But I think that Steed is asking us to question the promise of this so-called twin, or if you will, digital twin. What are we really aiming to replicate with that twin? Is it only the streets, the buildings, the urban systems, or is it actually us? Our own activity, our own behavior, social interactions, and experiences in the city. Now, I want to argue that after 60 years, after 6 decades of digital twins, it might be a time for us to go beyond the buildings and the systems and start to look at ourselves through these tools. And I think that there is a great opportunity in this technological moment. We are in the midst of a technological moment in which traditional computation is being challenged by the lack of rules, the inaccuracies, and some might even say the humanization of computational systems. What if we no longer just model buildings and streets, but also the way people move, feel, and interact in the city? What if we create and move beyond building tools that optimize cities to adopt technology to better understand the human behavior and experience in the built environment? I think finally, and most importantly, what if instead of this top-down and highly centralized design process, we can harness technology to crowdsource and amplify the voices of many? With that, happy to take some of your questions. Thank you.